Hi, my name is Ava Griffin. I'm a computer animation major. I'm currently enrolled in a Fundamentals of Physics course. My professor's name is Jay Murphy, and today I'm going to be talking about the concept of motion, or more specifically, Newton's laws of motion. Most of us, if not everyone, are pretty much familiar with all three of these laws. I'm pretty sure most of us have quoted the third law, whether it has something to do with physics or not. In any case, let's quickly go through these laws one by one so we can review them. It's going to be pretty much going back into fourth grade all over again. So the first law states that every object persists in its state of rest or uniform motion in a straight line unless it's compelled to change that state by forces impressed on it. So basically, an object's going to stay in motion until an external force is going to stop it. So as you see here, as I roll this ball of tape, it's going to roll at that speed until my hand goes and completely stops it or simply slows it down. If I don't roll it at all, it's just going to stay there completely motionless, just like a good little tape would. The second law states, force is equal to change in momentum per change in time. For a constant mass, force equals mass times acceleration. Basically, a change in velocity will occur when a force is applied. So here I am again, rolling the tape at a constant state of motion when I apply force from my hand to make it accelerate in velocity. Or perhaps I'm going to slow it down. Clearly it's a mystery. Don't know what my hand's going to go and do. Clearly, if this ball of tape were bigger, then my force would need to go and change in order to increase or slow down the velocity. So the third law of motion states, for every action, there is an equal and opposite reaction. So now I see me bouncing the ball of tape against the floor. The ball will go and push against the floor, and the floor is going to push the ball back equally and oppositely in the direction that I bounced it. So you might be asking, why is it that I chose to talk about the Newton's laws of motion? Well, it was kind of simple. We were going back to fourth grade and having like that moment between us. Not really, obviously. I chose this topic because computer animation is all about motion. You're animating things. You're making inanimate objects move, making them come to life in every way. Computer animation is clearly all about motion. So if I wanted to go and animate this piece of tape rolling anywhere without me going and touching it, I would need to be familiar with the laws of motion to make the animation of it seem believable in some way. In general, physics and animation are going to go hand in hand with each other. It's one thing to animate something with no care for real world physics. We've all taken games and seen where you can throw a rag doll around and nothing goes and affects it in any way except what it's bumping into, but you can tell it's fake. It's not believable to any type of audience, obviously. It just kills a few minutes, or for some people, I'm sure, a few hours. So knowing and being familiar with Newton's laws of motion, that's your important base for any computer animator.